Hello everyone. So here we will be seeing the Millman's theorem and then we will be solving the assignment. Okay. So just consider it as a question only. Forget about the theorem or anything. Just consider it as a question. So what will be your V naught value? There are multiple ways you can find V naught value. You can apply nodal analysis. V naught plus 2 by 2 plus V naught by 0.97 plus V naught minus 3 by 3 plus V naught minus 5 by 5, and then you will get the value of V naught. This you can do. And also what you can do, you can convert this voltage source into current source. Okay, so like this is a simple problem, but in some complex problem it will be helpful for us if we convert the voltage source into current source. Okay, so this voltage source 5 volt and 5 ohm resistance is there. So 1 ampere current source, 2 upward direction and 5 ohm resistance in parallel. Okay, so this is how it will be converted: 1 ampere current source and 5 ohm in parallel. Same with the next one. What will happen? 1 ampere current source and 3 ohm in parallel. 1 ampere current source and 3 ohm in parallel. And what about the next one? In the next one, 1 ampere current source downward, right? 1 ampere current source downward and 2 ohm in parallel, and then 0.97. 2 ohm in parallel, and this is 0.97 ohm, and this is the V naught value that you are looking for. Now these current sources are in parallel: 1 ampere current source, 1 ampere current source, and 1 ampere current source. So total current can be added, right? If voltage source are in series, we can add them up, right? V1 plus V2 plus V3. Let's just assume this is V1, this is V2, this is V3. So what will be the potential here? From here to here you will go V1 plus V2 plus V3. The potential here will be V1 plus V2 plus V3. Similarly, if current sources are in parallel, like 1 ampere current source, then here I am having 2 ampere current source, and here I am having 3 ampere current source. So what will be the total current here? 1 plus 2 plus 3. The total current will be 6 ampere. So current sources can be added, right? So 1 ampere current upward, 1 ampere current upward, and 1 ampere current downward. That means total current will be 1 ampere downward. And total resistance will be this resistance parallel with this resistance, parallel with this resistance. So basically, my current would be 1 ampere current upward, and my resistance would be 5 parallel with 3 parallel with 2, right? 5 parallel 3 parallel 2, and then I have a V naught. This will be my V naught. So I have to calculate it. I will bring the calculator. So basically this equivalent will give me 0.97 ohm only. Okay. So what will be my V naught? V naught will be, this 1 ampere current will be divided into two parts: 0.97, 0.97. So 1 ampere here, what will be the current going? That will be 1 by 2 ampere into the resistance, that is 0.97 ohm. Total I will get around 0.48 volt. Okay, so this is my V naught value. There are multiple ways you can find. I just wanted to tell you about this method. That's it, nothing else. Okay, so this is also a method. From there you can find that value of V naught. You can convert the voltage sources into current source. Now what we will be doing in this question, this is also a question. In this question we will be converting current source into voltage source. Now here if you find the value of current, it will be a bit hectic task, right? How you can find the current? Like 3 ampere current is going that way, and 5 ampere going that way. That means 2 ampere current is going that way. And now 3 ampere here, 2 ampere here, that means 5 ampere current here. And if this is 5 ampere and this is I ampere, then this will be 2 plus I. Then this will be some 5 minus 2 minus I. So that's how you can find the current. Okay, but it will be a bit hectic task, right? It will be hectic. Like it will there will be a lot of calculation. So what you can do, you can convert this current source into voltage source. You can convert this current source into voltage source, also this current source into voltage source. So how will you convert? So 1 ohm in series with 5 volt resistance, 1 ohm in series, sorry, 5 volt battery, then 2 ohm in series and 6 volt battery. 2 ohm in series and 6 volt battery. And then 2 volt and 1 ohm, 2 volt battery and 1 ohm resistance in series. But what will be the direction of battery? Downward, right? Direction will be like this. Got my point? Because the current direction is downward. So 2 volt battery and resistance is 1 ohm. Like in the exam, you will not have to draw it, right? If you have enough practice, if you have studied transient response and everything, you will be having enough practice with it, with these circuits. So you will not have to draw it. You will be able to understand, okay, this is what is happening here. So there you will be solving it quickly. Okay. Now what is the equivalent battery? 5 plus 6 minus 2, right? That means 9 ohm, 9 volt battery. And what is the equivalent resistance? 5 plus 2 plus 1 plus 1. So 9 ohm resistance. So basically what is happening? Total 9 volt battery and 9 ohm resistance. Basically you are getting equivalent of 9 volt. Have you got it? How 9 volt? Like in upward direction 5 volt battery is there, and in upward direction 6 volt battery is there. So 5 plus 6, and in downward direction 2 volt battery is there. So 5 plus 6 minus 2. So 9 volt. And what is the equivalent resistance? 2 plus 1 plus 1. 4 in series with 5. 4 ohm in series with 5 ohm. So they are asking you the value of current. They could have asked you the value of V naught as well, right? That they could have asked you what is the value of this. So it would be 5 volt, and what will be the current? Current will simply be 9 by 9. That means 1 ampere. Okay, well and good, easy question. So only thing we have to remember is that we can convert the voltage source into current source as well, and current source into voltage source as well. So if these kind of questions are coming, instead of writing like this, V naught plus 2 by 2 plus V naught minus 3 by 3 plus V naught minus 5 by 5 plus V naught minus 0, V naught by 0.7 equals to 0. So this will be a big calculation. Instead of that, we can convert the voltage source into current sources. So now one current source and one resistance and one more resistance as well. So our network will be reduced and we can solve the problem quickly. So that's how you solve the problem. And this theorem is known as Millman's theorem. You don't need to remember. No one will ask you what is Millman's theorem. They will just ask you the question, and that's how you can solve. Okay. Now we will see the assignment. Okay. Let's move on to the assignment now. Okay. So now we will be solving the assignment. So I hope you have attempted it on your own. So the value of current is given. You need to find the value of V. Okay. So it could be an easy problem, I guess. So what is the equivalent resistance we see here? That is 40 ohm. Here we are having 40 ohm. And the current is 5 ampere. So if in 40 ohm 5 ampere current is going, that means certainly in parallel 5 ampere current would have been going, right? Or how you can say, in 40 ohm, if there is 5 ampere current, that means it is having 200 volt across it, right? It is having 200 volt across it. Now the same voltage drop will be there across the 40 ohm resistance. That means 200 by 40, that means it will also be having 5 ampere current. That means from here there would be 10 ampere current, because 5 plus 5, 10 ampere current. That means it would be giving it a drop of 50 volt. So what will be V? V will simply be 50 plus 200. That would be 250 volt. Got my point? 5 ampere current here, that means same 5 ampere current would be flowing in this direction. That means it would be giving it a drop of 200 volt. And if 5 ampere here, 5 ampere here, that means 10 ampere current would be flowing from 5 ohm resistance. So 50 volt drop here and 20 volt drop here. So total 250 volt drop. In this question, you need to find the value of Vx. Okay. So let us assume this point is ground. Okay. So what will be this point? This will be 4ix. This will be 4ix plus, this point will be 4ix plus Vx, right? If this is 0, this is 4ix, this will be 4ix plus Vx, no resistance involved. So simply this will be 4ix plus Vx. So one equation I can write down from here, that is 4ix plus Vx by 2 is equal to Ix, right? So from here I can see Vx is equal to minus 2Ix. This is equation 1. Got my point? I just wrote down the current in this branch. 4Ix plus Vx by 2 is equal to Ix. So Vx is equal to minus 2Ix. Now I need to write more equations. So how can I write? Look, minus 4 ampere current is going upward. That means 4 ampere current is going downward, right? This 4 ampere current is going downward. And what is the current in this branch? Can you tell? In this branch, what is the current? Vx by 8. How did I tell? Across 8 ohm, there is Vx voltage drop. So current here is Vx by 8. That means what is the current coming from here? Vx by 8 plus 4 ampere. Vx by 8 plus 4 ampere current coming from here. 4 ampere is going that way and Vx by 8 current is going that way. Now from here I have 10 ampere current. So what will be the current at this side? What I am saying, I have some current this side. I don't know that. I don't know the value of this current. I have 10 ampere current coming from here and Vx by 8 current going there. This current is Ix. The current that is going here is Ix. So Ix is a outgoing current. Vx by 8 plus 4 is also outgoing current. But 10 ampere is a incoming current. So from here as well we get a relation. So what is the value of Ix? Ix is minus Vx by 2. So here I can put minus Vx by 2 plus Vx by 8 is equals to 6 by equation 1. Right? From here I can get the value of, so it would be minus 3Vx by 8. Minus 3Vx by 8 is equals to 6. So from here I get the value of Vx. Instead of doing this, I will go to the next page only. 4 and 4, so it would be minus 3Vx by 8. Minus 3Vx by 8 is equals to 6. So Vx is equals to minus 16 volt. Is it correct? Let me check it once again. Yeah, so the answer is correct. Vx is minus 16. Okay. It is minus 16 volt. Okay, let's move on to the next problem. Here you again need to find the value of Vx. This will be a bit calculative, but you have to reduce the calculation part. So how will you reduce it? That is the task here. Look, if I start applying some nodal and everything here, it will give me problem, right? Because there are two current paths, so it will give me a problem. I would want my complete circuit to be in series combination, right? If I can take my complete circuit into series combination, I can just apply one KVL equation and it will be solved. But here there is this parallel combination, this parallel combination. So I would want to take them into series combination. How can I take? Convert this into voltage source, convert this into voltage source. So what will be the equivalent circuit? 40 volt remain there as it is. 8 ohm there remain as it is. Drop across it is Vx. Now what will be the direction? Here it is not completely seen, that is 3 ampere. Okay. So what will be the direction of the battery? Tell me. If I make a battery, what will be the direction? Direction will be minus plus, right? Why is it so? Minus plus, because from plus terminal the current is getting out. That will be 30 volt with 10 ohm resistance in series. Here 10 ohm and with how much resistance in series? 10 ohm resistance in series, and what is the battery? That will be 20 Vx, and the direction would be plus and minus because current is upward and current is here in this question, so it will be 30 volt in this direction, right? And now we will just make this connection. Now you just need to apply the KVL here. Tell me what is the current in this branch? Let's assume my current is X, my current is I. So what is the value of I? In terms of Vx, that is Vx by 8. Are you getting my point? Did you get my point? So I am just applying my KVL from here. Okay. So 40, then minus Vx, then plus 30, then the drop will be in this direction, plus minus plus minus. So minus 10 into Vx by 8 minus 10 into Vx by 8 minus 20 Vx is equals to 0. That's it, right? So what will be the solution? Here you are having 70 volt this side and all Vx part is negative. Let me solve it. 10 by 8 into 2 plus 20 plus 1, so 23.5 Vx. So Vx will be 70 by 23.5, that we get reciprocal and into 70, 2.97 volt. Okay, so this is the final answer. Okay, well and good. Let's move on to the next problem. So why did I take this problem? So that I could tell you we want to make a one loop that's completely in series. So only one loop is there. So I could convert it like this and then I could found the value of Vx. Okay, I have to take it down. And now these are some good questions. Okay. So it is given that in the circuit shown in the figure for different values of R, the value of V and I are given. You have to, and remaining elements are same. If R is equals to 3 ohm, what will be the value of V? Okay. So if R is infinity or V is 5 volt, tell me what is 5 volt? Thevenin's voltage. Why so? You are doing nothing with the Vs. Vs remains there as it is. So let's just solve it on the next page. So your Vs remains there as it is. So I will just copy this circuit. Now we are solving it. Vx remains as it is, and when R is equals to infinity, when R is equals to infinity, that means open circuit. This will be open circuited, right? And when R is equals to infinity, you are getting 5 volt here. You are getting 5 volt here. So what do you think what it is? What is Thevenin voltage? The load is open circuited and we get the value of voltage there. That is Thevenin voltage. You don't do anything with the Vs. So open circuited load, okay, and then you calculate the value of voltage there. So this value is simply Vth, that is 5 volt. Now this was the first condition given. What is the second condition given? R is 0 there. R is 0 and I is 2.5 ampere. Okay. So R is 0 this time. 0 R means shorted, right? So it is shorted now. This is shorted now. So tell me, what is this? What is this showing? What is your short circuit current or Norton's current? What is your short circuit current? Output is shorted and then you find the value of current in that. So this is what it is showing. This is short circuit current and that is 2.5 ampere. This current was 2.5 ampere. So this is short circuit current, that is 2.5 ampere. Now you have VTH, you have ISC. What you can find? RTH. RTH or R Norton, that is 5 by 2.5. That means 2 ohm. So simply at here you can replace your complete circuit with VTH and RTH or ISC and RN. I will prefer VTH and RTH. Okay, so I will replace this much of circuit with only one resistance and one voltage source. Okay, what is the value of voltage source? That is 5 volt, and what is the value of resistance? That is 2 ohm. So basically my complete circuit is replaced with the 5 volt battery and 2 ohm resistance. And then what do? I connect a load of R value is 3 ohm. So I connect a load of 3 ohm and then I calculate the value of V. What is V? V is the voltage across 3 ohm. Basically V is your voltage across 3 ohm. Okay, this is 3 ohm and this was 2 ohm. So what will be the value of V? That will be 3 by 5 into 5, that means 3 volt. Well and good, easy question. What did we do? Whatever the information that is given to us, that is everything for us. Okay, from there only we need to find something. And whenever there is a question like some blocks are drawn and they are finally asking you some voltage or current, always try to reduce that block to simple equivalent VTH and RTH. Whenever there is some blocks and everything, all these things are given, always try to reduce that block to VTH and RTH and then find the whatever that they are asking. So whenever gate exam or any other exam has asked these kind of question, they just want you to find the Thevenin equivalent and then find it. Okay, so from the given information you can find the Thevenin equivalent. R is equals to infinity, that means open circuit voltage. And what is open circuit voltage? That is VTH only. And R is equals to 0, that means short circuit current. And what is short circuit current? That is ISC. From there you can find the RTH, and VTH is already there, so you can find the value of V. Let's move on to the next question. I guess this is also not clearly visible to you. Now it is visible to you. In the circuit shown, V is 3 volt for E equals to 1 and I equals to 0. And V is 2 volt for I equals to 2 and E equals to 0. When E is equals to 1 volt, I is replaced by a resistor of 2 ohm. What is the value of V? So tell me. I think you should solve it on your own. What is the first circuit? I will just copy it and then quickly paste it. What is the first information given to you? First information given is I is equals to 0. If I is equals to 0, then E is 1 volt and V is 3 volt. Okay, I is equals to 0. What do you mean I equals to 0? Open circuit, right? So what is this? E is equals to 1 here. Okay, and V is they are giving, that is 3. So what is this 3 volt? That is VTH, because we are talking about open circuit voltage here. So we have the VTH value now. Now there must be some other information as well, right? So from other information as well we can find something. The other is that when E is equals to 0, your V equals to 2 volt and I equals to 2 ampere. When E is equals to 0 volt, when E is equals to 0 volt, that means this battery will be simply shorted, right? This will simply be shorted. Then V is 2 volt and I is 2 ampere. V is equals to 2 volt and I is equals to 2 ampere, right? That means this is 2 volt and there is 2 ampere current flowing through it. Tell me what you can find from it. How do you find Thevenin resistance? How do you find Thevenin resistance? You nullify the effect of energy sources, independent energy sources. Nullifying the effect of independent energy sources, at load you connect a voltage source and get the current out of it, or you connect a current source and get the voltage across it. This is how you this is how you get the RTH. This is what you are doing here. Short circuit the load, you connected a current source and getting the voltage across it. What is the voltage? That is 2. What is the current? That is 2. That means your RTH is 1 ohm. Simply your RTH is 1 ohm. Now tell me why this information was necessary here. That when E is equals to 1 volt and I is replaced by a resistance of 2 ohm. So why they are giving me E equals to 1 volt? Why is it necessary to give? Because if E was something else, let's assume in this case E was 5 volt and whenever you were asked E is your 1 volt. So at that time VTH will change. Are you getting my point? Let's just assume this is my circuit, R, R and R. This is 5 volt, this is R and this is R. And I am asked to find the VTH here. Tell me what will be the VTH? 2.5 volt. If I replace this 5 volt with 1 volt, what will be my VTH? 0.5 volt. VTH has reduced, right? So that's why they are giving me the E is similar as 1 volt. Here it is similar as the previous case. I found VTH equals to 3 volt for E is equals to 1 volt. I found VTH equals to 3 volt for E is equals to 1 volt. So now for E equals to 1 volt only, I can replace the circuit with 3 volt battery and 1 ohm resistance. Okay. In final circuit, in final VTH and RTH, E will not come. But this circuit is valid for only E equals to 1 volt because I found the value of VTH with respect to E equals to 1 volt. Are you getting my point? If E was something else, my VTH would have been something else. So that's why it was necessary to give that E is 1 volt here. Okay. And I is replaced with 2 ohm resistance, and what is the value of V? Okay, that we can surely find. Okay, so my I will be replaced with the 2 ohm resistance. So basically, what is my VTH? My VTH was 3 volt and my resistance is 1 ohm. RTH is, current is replaced with the 2 ohm voltage source, and you need to find the value of V. This is the value of V. Your V will simply be 2 by 3 into 3. That means it will be 2 volts. That is the answer. That's it. Okay. From the given values, you can always find something. So in the given circuit, Vs is a constant voltage source and IL is a constant load. Okay. Constant current load it is. What will be the value of that? The value of what? The value of IL. The value of IL that maximizes the power absorbed by the current source load is. Look, do you remember any formula, anything for these kind of circuit? No. What we need to find? The power in load IL. What will be the power in load IL? The current and the voltage across it. We don't know the voltage, we have to assume it. It will be V. We have to maximize it. We have to maximize it. Now, V we have assumed, right? V we have assumed. So now we have to find V in terms of Vs, R and IL so that we can replace it here and then we can simply differentiate it. So I will find V in terms of Vs, R and IL. So Vs minus V by R is equals to IL. Are you agreeing to it? What is the current here? That is IL. That means Vs minus V by R is equals to IL. So what will be the value of V? Vs minus IL R is equals to V. This is the equation 2. Simply put it in equation 1. Power of IL, that would be IL into Vs minus IL R. So it would be Vs IL minus IL square R. Now you have to find the value of what? Current IL, right? You have to find the value of current IL so that maximum power is transferred. So with respect to what you will differentiate? You will differentiate with respect to IL only. So differentiating with respect to IL only. So Vs is a constant quantity. So Vs will remain there as it is. Differentiation of this will give me 2IL into R and it will go to 0. So IL value will be Vs by 2R. That's it. Okay. And this is my IL value. Okay. Got my point? Voltage source, current source, voltage V, resistance R. So power delivered I wrote, then I found the value of V, then I put the value of V there, then I got the complete expression into constant terms and a voltage and the current IL. So I need to find the value of IL that maximizes the power absorbed in the current load. So I have to find the value of IL, so I will differentiate with respect to IL only. So from there I get the value of IL, that is Vs by 2R. Okay. Now there is a resistive network and there are 3 sources there. Okay. And each one is consuming some power. In the circuit, the power consumed in the resistance R is measured, okay, when one source is acting alone. These values are 18 volt, 50 volt, 50 watt or 98 watt. When all sources act together, the maximum and minimum power can be, okay. So one of the source is acting. Let's just assume first E2 is acting. So if E2 is acting, the power in the resistance R is measured as 18 watt. Then if only E3 is acting, then 50 watt is measured, and only E1 is acting, then 98 watt is measured. So these powers are measured. Now you have to find the maximum and minimum power. Okay. Now you don't know the direction of current. Let's just assume because of E1, this is the direction of current. Okay, because of E2, this is the direction of current, and because of E3, this is the direction of current. So what we have studied? We have studied that formula, that P total would be, the formula is this, P1 plus P2 plus Pe3 whole square. Is this formula correct? No. In formula we have studied plus minus because you don't know the direction of current. Now they are asking maximum and minimum value. So for maximum, what will be the case? For maximum, what will be the case? Tell me. All will be added, right? These all will be added. This will be the case for maximum, right? So what will happen? Root 18 plus root 50 plus root 98, okay, whole square. What you can write it as, that is 3 root 2, right? You can write this one as, this is 50, so 25 into 2, so 5 root 2, and this one as 7 root 2, right? So it will be 5, 6, 7, 8, 15 root 15 root 2 whole square. It will simply be 450 watt. Okay, so this is the maximum, 450 watt. The minimum will be 2 watt by option, you know. But what will happen for minimum? You tell me. For minimum, you tell me. You have 3 terms, root, not 3 terms, not root 18. I will just write 3 root 2, 5 root 2, and 7 root 2. And square will be there. You need to get this minimum. How will you get this minimum? Let's just assume I put plus here and minus here and plus here. So 8 minus 7, that is root 2 I am getting. Okay, one option is root 2. Okay, now what I do? I put minus here and plus here. Then what I am getting? 8, 7 plus 3, 8, 8 minus 5, that means I am getting 3 root 2. Okay, now what I do? I put both of the side plus and minus here. So what I am getting? 12 minus 3, that means 9 root 2. So basically you will get the minimum at only first condition only, that was over this condition, that these two are added and this one is subtracted. Minimum and though 2 minimum are added and 1 maximum is subtracted. So 8 root 2 minus 7 root 2, that means it will give me root 2 square equals to 2 watt. So this is the minimum condition only. You can try other condition as well, but they won't give minimum results. Okay, you can try other condition as well. Like for 3 sign is there, 1, 2, 3. So there are possible 8 combinations, right? There are 8 possible combination, that it can be plus plus plus, it can be plus plus minus, it can be plus minus plus, it can be plus minus minus, like this. Okay, and can be minus, these kind of things can be there. So there are possible 8 combination, but the combination that will result in the maximum value is, that is plus plus minus. Okay, or it can be minus minus plus, minus minus plus. So basically because of 18 watt and 50 watt, the direction has to be the same, and for the other one it has to be opposite. Got my point? Okay, so the power is 2 watt. Let's move on to the last question of our this chapter. Okay, this will be the last question of our chapter. So this question was asked in my exam when I wrote the GATE exam in GATE 2022, and I got it wrong. Okay, and I spent around 10 minutes as well. Still I got it wrong. This was very easy question. Because of the pressure of the exam, I got it wrong. Okay, so what is given there? 10 volt is battery is there. The similar kind of question that we have solved previously. 10 volt battery is there, and now they have drawn a graph between V2 and minus I2. Notice that it is V2 and minus I2. Okay, so the graph is drawn. So can I write the equation between V2 and minus I2? First I will do this thing. V2 is equals to Y is equals to mx plus C. What is the slope? Slope is minus 1 by 4 milliampere. right? So minus 1 by 4 milli minus I2 plus C. What is C? At y-axis, at what point it cuts? It cuts at 5. What I applied here, y equals to mx plus c. This is what I have applied. Simple equation of line. Y is v2 equals to m. What is the slope? That is 1 by 4, minus 1 by 4. And what is x-axis? X-axis is here minus I2, not I2. It is minus I2. So minus I2 plus at y-axis, what is the point where it cuts? That is 5 volt. Okay. So this is the equation. So basically you are getting v2 equals to 250 I2 plus 5. Right? This is what you get. Here I2 is in what? If I am putting 1 by 4 milli here, that means I am considering I2 in ampere, right? And V2 in volt. So this is what is given. Now your load is replaced with something. After some time, your load is replaced with something. That means what they want. You replace this complete circuit with VTH and RTH. This is what they want. Okay. So how can I find VTH? For VTH, what will happen? I2 has to go to 0. I2 has to, this current has to go to 0 so that it is open circuited. So for VTH, I2 should go to 0. So I2 should go to 0 ampere. That means V2 will be 5 volt and that will be your VTH, right? This is my VTH. Can I directly find RTH? When this question came, many of the teachers produced the solution and they just said that 1 by 4 milli, that means 250 ohm is the RTH. Is this correct? Think about it and tell me, is this correct? 1 by 4 milli is your RTH. Is this correct? For RTH, what do? You short circuit the input and then you find the RTH at load. Are you short circuiting the input here? Are you short circuiting the input here? You are doing something in this equation only. You are not doing anything with the input. But for finding RTH, you have to short circuit the input, right? When V1 is 10 volt, then this is the equation between V2 and I2. If V1 is 5 volt, your equation will change. So you are not doing anything with the input, right? You are not short circuiting that. One thing one can say that my V2 and I2 are not dependent on the input. My V2 and I2 are not dependent on the 10 volt. So that's why I can do anything. Like between V2 and I2, the equation is independent of the 10 volt. That is the input. If my equation was something like this, V2 equals to 250 I2 plus 5 plus V1, then the whole scenario would have been changed. Okay, then the question would have become very interesting. If my V2 would have been this, okay, then you can't really find the RTH. Sorry, you can't really find the what do we call RTH like this. And even in this equation, 1 by 4 milliampere, 250, that is fine. Just because your V2 and I2 are not dependent on it. V2 and I2 are not dependent on the input voltage. That's why it is fine. So instead of that, what will be the correct approach? We better find ISC. Okay. We better find ISC. So what will be ISC? For ISC, V2 should go to 0, right? But let me make this circuit here again. Okay. So what is my V2 should go to 0? That means R will be 0. If V2 is 0, that means this complete path will be shorted, right? And what is my I2? This is my I2. But what is my ISC? ISC is the current flowing in this direction always. Like this is some network, and if I short circuit this, what is the ISC current? That is this. I told you about the direction, right? And what is VTH always? VTH is always from up to positive direction, and ISC only flows from up to down, right? So what is my ISC? ISC is like this, but I2 is given like this. So my ISC is negative of I2. So my ISC is equals to minus I2. So this is one thing that we should take care. Okay. So what we have calculated, we have to put V2 equals to 0. So 250 and I2 is negative of ISC. So here I will put minus ISC plus 5. I2 plus minus ISC plus 5. Yeah, okay. So ISC you are getting is 5 by 250 ampere, right? 5 by 250 ampere. This is what you are getting as ISC. Okay. Now what you can do? You can find the value of RTH, right? So my VTH is how much? 5 volt, and my ISC is 5 by 250 ampere. Okay, so my RTH would be 5 by 250. So simply it would be 250 ohm. Okay, so here by doing this analysis as well, you are getting 250 ohm, but the actuality is that you are not short circuiting the input, and since your V2 and I2 are not dependent on the input, then only you are getting the right answer by this curve. Otherwise you would have got the wrong answer. Okay, so you should be knowing that in these kind of question, instead of finding RTH, you should find ISC, because in ISC simply you have to short circuit the output. You are not doing anything with the input. Input is there as it is. So in ISC you are just short circuiting the output. Okay. So in these kind of question, you should prefer finding ISC, not RTH. Okay. So now this A and B, this is replaced with this kind of circuit. So you can simply find the value of what you simply need to find the value of I2. Okay. So now I have a 5 volt battery. I have a 5 volt battery and 250 ohm resistance. 250 ohm resistance, and this load is replaced with the battery of 10 volt and 1 kilo ohm resistance. 1 kilo ohm resistance and battery of 10 volt. Okay. And what is the current? What is the direction of current? That is this I2. So this is my I2. Okay. So what will be my I2? That would be 10 minus 5 upon 1k plus 250. That will be my I2. So I2 will be 5 by 1250. That means it will be 4 milliampere. So this is my answer. Okay. So my I2 was 4 milliampere. Okay, well and good, easy question. Just the slope is, just the curve is there, and you can write the equation. From there you can find the value of VTH and RTH. Okay, and then you can replace the circuit with simply VTH and RTH, and you can find the value of I2. That's it. Okay, so yeah, we have completed our network theorem. Okay, and now we will be starting transient analysis, and that will be very important topic and very interesting. Like I can guarantee you, this will, what you are going to watch is the best ever transient analysis if you have ever watched. The best ever, I can guarantee you. I can write it on a paper and sign it. Like I am not just bragging about it, just watch it once. Okay, just watch that transient analysis videos once. You will realize why I am saying so. Okay, and that is very important part. Sometimes 2 marks and sometimes even 4 to 6 marks question are asked from transient analysis itself. And that is very much necessary for analog electronics as well. So yeah, I do recommend you watching the further chapters. Okay, so we will be starting with transient analysis, and I hope you are very much comfortable with the network theorem now. Okay, so let's start with the transient analysis from next video, and please do share it with your friends. Okay, thank you.